Good afternoon, everybody.
Good afternoon, Prof.
Good afternoon, Prof.
How are you? I believe
We are
everybody
good.
is giving another 5 minutes to people to join so that we
I
start
might
at
I might join you in Raw Forum. If not today, then tomorrow I'm at campus, but I'm still finishing something.
okay.
Mm.
Good afternoon, Helen. Dr. Helen, how are you?
I'm not seeing Ellen there.
Okay.
She has
Okay,
not yet
5 minutes
joined, I
more.
think.
Hmm.
Yes, Prof. Good afternoon once again. Prof. Balawa?
I think you have all the content in the blog.
Yes, can we maybe start now since the number is now reaching to 200? It's much better than it was 5 minutes ago.
Okay, yes, we can start.
Okay, Prof, thank you. Good afternoon, dear participants. Once again, we are graced and happy to have you here today. Thank you so much for your commitment and for being here throughout. Our Forum Secretariat is doing this webinar series almost every year, sometimes even 2-3 times a year. And the only reason why it keeps coming up, it's really because of the commitment that we see in the participation. Because we see that indicates the demand of the subject area that you are being trained in. So we continue to plead for your patience, for your great participation, and also commitment to this type of training so that it encourages us to continue to bring more training such as this. So thank you. And once again, I just want to remind you that the webinar is live, and because it's live, it's on YouTube, and it remains on YouTube even after the trainings. So you can still catch up with day 1 up to today. We are in day 4 on our YouTube channel, the Forum Network on YouTube. Secondly, if you are asked to say anything or you want, first of all, if you want to respond to anything, you want to raise a question or engage with the facilitators, please do raise your hand, and we will be able to promote you to being a panelist. But we cannot automatically take you to the room. Once we give you a prompt, will appear on your screen, and you should accept the prompt so that you are able to get into the main session and be able to share your screen or probably ask your question. All questions should be raised in the Q&A so that it provides us with the facilitators to respond to each and every question and address them. In the chat is for engagement, for you to tell us where you are and how the session is going so far. Otherwise, the registration link is put up in the chat. Thank you very much and enjoy the session. Over to you, Prof, and the team. Thank you.
Selma, just a moment. Prof, just a moment.
Thank you, Selma.
Yes, I would like just to add on a registration form. There are people who just participate one day and they ask us for a certificate. So I wanted to make it clear that we don't give certificate for those ones who just participate 2 or 1 day. So we start from those ones who we give for those ones who participated from day 1 up to the last day, which is day 5 in this case. And also to request all participants, they have to fill the full name, which they would like to be in their certificate, because we struggle a lot the way some participants, they fill the name and later they start asking us the name how appears in the certificate. So please fill the way you would like to be in your certificate. Thank you so much. Thank you so much for your time, Professor Susan.
Thank you, Arthur. Thank you very much.
Thank you. Thank you, Arthur and Salma, for the introduction. We are going to continue with regression. I'll just briefly share the PowerPoint. We go through it briefly and then go to R. I thought that we should do some practicals today so that we can gain more than when we do only theory. So yesterday we talked about simple linear regression, where we said it's a regression between the response and one independent variable. We talked about assumptions under linear regression, which include data being linear related to the independent variable. The residuals or errors are normally distributed with mean 0 and constant variance. They are also not correlated, or they are independent. We also talked about multiple regression, which is a relationship between the response and many independent variables. And we say the assumptions under simple linear still hold under multiple regression. We talked about indicator variables where we have categorical variables which we think are important in explaining the variation in the response need to be included, and we say that those can be coded and then we include them in the regression. So today, let's turn to R and do some practicals, and then we will go on explaining all these. I'm left with explaining polynomial and indicator variables only, so we can do that during the practicals. So I will stop sharing the theory, and I want us to, all of us to turn to R. So I will open my R. And our script is called core and regression F. That's what you are going to use. So let me share. Okay. Okay, so that is the script that we are going to use. It's called core and regression. I give 2 minutes to everybody to open their R and then R Studio, and then make sure you have this script. Okay, so in the chat, has everybody opened R Studio? Can I see yes or 1, meaning you have R? Let's see. If you do not have the script, go to the Google Drive and download the data plus the script, put it in one folder, which we are going to be using. Okay. So then, okay, so let's start. My colleagues will share the Google Drive. Dr. Helen posts the Google Drive link in the WhatsApp chat or in the Q&A. Okay. Okay, so we are going to load the packages, and there are several packages that I've highlighted. So we are going to highlight them. And click run so that they are loaded onto your computer. It's just reminding R that you'd like to use some of those packages. And in case you see any package that you have not installed, then you use the install.packages. For example, maybe you don't have gmodels or lsrr or HIMSC. So just use install.packages, open bracket, quotes, then you write the name of the package and run. So just in case you don't have any of these, make sure I install them. Sometimes you get a yellow notification on the menu here saying install. So if you get such a notification, just click install so that the packages are installed. Once you install the packages, you have to load them so that they are active. The second thing we are going to do is to set our working directorate, and we are going to go to session window, set working directorate, choose working directorate. Session window, set working directorate, choose working directorate, click choose working directorate, and browse over to where you've stored your data sets. Browse to where you have stored your script. Browse to where you have stored your okay, then you click OK. Okay. So let's go, and now I'm assuming that everybody in the chat, have you set your working directorate, the Google link? Whoever has the Google link, please, let's see. So I have pasted the Google link. Unfortunately, I can only paste it to hosts and panelists. So if you are one of the panelists, can you please take it to everybody? So I have pasted it there. Dr. Thomas, can you inform Arthur to program so that we can post information in the chat to everybody?
Okay,
Please
let me.
inform them. Okay, thank you. Okay, so we are going to the second bit where we are going to import our data. Our data is called EggPP. It should be among the information in day 3 or the folder which was uploaded yesterday, 1st of October, 2025. So if you have the script, let's run line 29. Maybe it is different, but it says eggp assign read.csv in bracket eggp. We are trying to import this data set that we are going to use. Okay, so if you import the data set and then run eggp, you'll be able to get to see our data. Or you want to view. So eggp consists of water uptake, food uptake, and egg production. So I assume that everybody has opened the data. And once you have opened the data, before we run the regression or any inferential statistics, we do some descriptive statistics. And in this case, our descriptive stat for regression will be a scatter plot and correlation. Not yet, still installing packages, or have you gotten the information? from the Google Drive. So please download the information from folder named 1st October, which is day 3. The quicker we do that, the better. We will cover more information today. If we are too slow, okay, I'm giving you 2 minutes. Please let us have the script and be able to import the data called eggp. Remember, for you to be able to import it, you must have installed the corresponding package. So 2 minutes, we have 1 more minute. It's the same data you downloaded yesterday. It's the same data you downloaded yesterday. You just need to browse to the folder where you stored day 3 information. Thank you, Gladys, for sharing the Google Drive. Okay, so let's go ahead and import the data. Let's go ahead and import the data. Okay, thank you, Dr. Helen. Okay, if you have downloaded the script and run up to importing data, type yes. Type yes. If you have the data, type yes so that we can continue. The data is eggp in day 3 folder. I can see yeses, but not enough because we are 277. So I should see 100 yeses. Okay. Okay. So if you have the script already in R, what I'm saying is that the first thing we do is to load our packages. Load the packages. You highlight all these packages where you see library, in bracket the package name. Highlight them, select them. So you just have to select all of them and then run. Click run. After that, set your working directorate. Tell R where you've stored the data. That is setting the working directory. So you go to session, set working directorate, choose working directorate. Then you browse to where you have stored the data and click open. So what is going to happen is that you will see in the console a route, a path to show you where your data is. Okay, so after that, let's go to importing the data. It's eggp assign read.csv in bracket eggp.csv. That is importing our data from Excel into R. So when you run that and run the next, you will see in the console, you will see data which has variable water uptake, food uptake, and egg production. If you use the view command, you will see your data in the R Studio in form of a worksheet. So there we go. So you'll be able to see your data in form of a worksheet, just like in Excel. Then you can close that worksheet. If you go on top of the RStudio menu, you will close where there's egg P, just close, and let's continue. So we are going to visualize our data, and you can either use the plot command, scatter.smooth command, ggplot command to construct a scatter diagram. You will get the same result, only that one looks better and clearer than the other. If you have a problem, Edwin, go and install package Learner R. I can see somebody saying he has an error in the library. Go and library Learner R, go and install it. Thank you. Then let's plot. If you plot, you will see a graph coming up in the plot window in the right bottom corner. So I presume everybody sees that graph and you have it on your computer. If you look at that graph in the chart, what do you see? Let me see how you understand this diagram. It is a figure where the y-axis is water uptake and x is food uptake. So what do you see according to what is displayed in the diagram? What do we see? We learned that yesterday. We learned about scatter diagram. We learned about correlation. Okay, Gladys says linear, egg production increases with water, positive. Okay, thank you. Normal distribution. Oh my God, I'm Ahmed. There is no normal distribution here. It's just a scatter diagram. Okay, we shall see normal distribution later. Positive, perfect, yes. Positive correlation, okay. Linear, strong positive correlation, good. We see a strong positive correlation between water uptake and food uptake. Remember, we say that correlation does not mean causation. So food uptake does not cause the birds to take more water. You can only confirm that if you perform the experiment. You measure the food, give it to the different birds, and then give them water and see how much water they are taking with varying amount of food. Then you'll conclude that food uptake increases water uptake. Okay, so that is when we use the plot command. You can use scatter.smooth. You're going to get the same thing. And then ggplot, you're also going to get the same thing, only more beautiful. It has a confidence band around it. Then from there, we say that we also use, okay, thank you. We also compute correlation coefficient to find out whether there's a linear association between water uptake and food uptake. So we are assigning that a result as ASS, and then core.t test is the correlation command to produce correlation coefficient, and then the method is Pearson. So we run that, and then run AS, and we see correlation. Does everybody have these results below here in the console? Everybody has the results? Okay, no, keeping quiet means you have the results. Okay, let's continue. So in the results, you see there's a T value, degrees of freedom, a p-value of 4.02 times 10 to the power minus 8. It says alternative true correlation is not equal to 0. So implying that the null hypothesis is that there is no correlation between water uptake and food uptake. So if we get a small p-value, it means that we have evidence, reject the null, and conclude that there is strong positive correlation between water uptake and food uptake. The correlation coefficient is 0.97787, which is approximately 97.8%. So it is strong positive correlation This test also gives you the confidence interval for your correlation value. So these are the possible values which the correlation coefficient can take. Okay, so let's go ahead, and we can also use ggScatter to construct a scatter diagram, but within ggScatter, we can ask R to add a regression line, confidence interval, correlation coefficient, and we also specify the method as Pearson. Okay, so we run ggScatter, everybody run ggScatter. So in the chart, what do you see in the ggScatter? In the chart, what do you see in ggScatter? In the chat, what do we see? Sheila says error. What error do you have? Can you give details? Write it in Q&A and my colleagues will help you. Somebody else also is saying error. Okay, a plot of correlation, strong positive. We see a p-value corresponding to R. Yes, thank you. We see R, which is a correlation of 0.98, strong positive correlation. Function ggScatter not found. It means you didn't install package ggplot2. So my colleague Thomas will help you with that. There is a problem in the webinar that somebody has an error, function ggScatter is not found. So we have R and P value indicating a strong positive correlation. We also see a regression line, and we see that the points are close to the regression line. We also see a confidence band, which is in form of gray. Okay, so after that, we know that there is a strong positive linear correlation between water uptake and egg production. So what we are going to do is to run a regression and investigate that relationship, whether it truly exists. Okay, so for us to run a model that water uptake is a function of food uptake, we use LM. LM stands for linear model. So we are going to give that whole analysis a name called model and assign LM, which is the command for regression. Water uptake is a function of food uptake, comma, data is equal to egg P. So when you run that, so let us run the model and then print what is in the model. You get the intercept and the slope corresponding to food uptake. We remember that for every unit intake in food uptake, our water uptake increases by 2.733. And when food uptake is 0, water uptake is minus 62.513. The same analysis for you to get more results, you need to run summary in bracket model. It gives you more results, so let's run that. And you see that now you have the coefficients printed out, you have R squared printed out, you have residual error printed out, F value, and the corresponding P value. So here we see that our coefficients, the intercept is minus 63, the slope is 2.7. They have their corresponding T value and P values. Yesterday we said that the P value corresponding to the slope of uptake is testing the linear relationship between water uptake and food uptake. And because it is smaller than 0.05, we have evidence to reject the null and conclude that there is a strong linear a significant linear relationship between water uptake and food uptake. Now, when we look at multiple R squared, which is the coefficient of determination, we see that the R is 0.9568. So this implies that 95.62% of variation has been explained in water uptake by the regression model. We also have, no, I don't see the R, but we'll see it later. Then you also have the adjust R. Okay. So another way to get regression is by using the command AOV of, which gives you an analysis of variance table. So the results are stored in mode 2 or model 2, which is assigned to a command AOV. Water uptake is a function of food uptake, and the data is in egg PP. So let's run that. And we get an analysis of variance table where we have the degrees of freedom, the residual degrees of freedom, the sums of square, mean square, F value, and P value. You remember that they calculated an F value in the upper result, which is 218.6 on 10 degrees of freedom, where 1 degree of freedom is the numerator degrees, and the P value is similar. So this ANOVA also is testing overall there is a significant linear relationship between water uptake and food uptake. Any questions so far in the chat? Any question? What does a negative estimate mean? What is the negative estimate? P-value clarity. The p-value is 4.02 times 10 to the power minus 8. We are testing the assumption that there is no linear relationship between water uptake and food uptake. And our p-value for that assumption or hypothesis is 0.05. So we assume that the null is correct at a p-value of 0.05. So if we get a smaller probability, it implies that there is no evidence to support the null, because the chance that the null is correct has reduced to 0.0000402, which is smaller than 0.05, indicating that we have evidence to reject the null and conclude that there is a linear relationship between water uptake and food uptake. The other is linear model, not linear correlation. Linear model and ELF seem to do the same task, yes, but under OV we get an analysis of variance. What does adjust R squared mean? Adjust R squared has the same interpretation as multiple R squared, only that adjust R is not affected by you adding more variables in the model. It is already adjusted for any parameters you enter into the model, but the interpretation is the same. It indicates that 95.19 of the variability has been explained in water uptake by the regression model. Okay. We have a negative intercept. Remember that the intercept is the value of y when x is equal to 0. When water uptake is equal to 0, then the bars I could say they take less water as compared to when they have food around them. But we can go further and investigate the biology of birds to see whether how much water is taken when they are not eating. Or when they are not eating, do they take water or they don't take water? So that now goes into biology. Okay. Sometimes the intercepts don't have a meaning for certain biological processes. But for some biological processes, yes, they do have a meaning. The F statistic, we talked about it yesterday. We compared the calculated F with the tabulated F on 1 and 10 degrees of freedom. And we said in case the calculated F is greater than the tabulated F at 5%, then we have evidence to reject the null and conclude that there is a significant linear relationship between water uptake and food uptake. Okay. I think we can now continue. In the script, there's more explanation, so you can read the explanation. So let's scroll down and go. If you run conf int, it gives you confidence interval for the slope. Remember that yesterday we talked about the assumptions. We can now test the assumptions, and for you to test the assumptions, you must have run the model, which model we've already run. We are calling this model 2, and when we run, it is in the memory, and when you summarize, still has the same output. But now we want to divide our window into a 2 by 2. So we run this command, pow in bracket mfro 2 into 2. For those who have not gotten the script, it is in the Google Drive. And when we write plot model 2, it produces the residual plots for checking the variance, for checking the assumptions. It's complaining that the margin too large, so I'm going to reduce the margin. And then run plot model 2. So when we do that, we get 4 graphs. Has everybody gotten 4 graphs in their in the environment window? No, in the plot window, sorry. Do you all have residual plots like I do? How do you reduce the margin? Go to view on the menu under RStudio and click zoom out twice. If it doesn't work, then you zoom out maybe 3 times. So you click zoom out, then it will reduce the margins and you're able to get the plots. Okay. Alpha, you said do again. I don't know what to do. What part should I repeat? I don't know. You need to tell me what to repeat. Okay, so now let's interpret this. I'm going to stop sharing and I want to zoom out. I want to zoom this out and then share. I've zoomed in the plot. So that is the plot we've gotten. And in this plot, we have a plot of residual versus fitted values. We have a QQ plot. We have a scale location plot and residual versus leverage plot. So in the residual versus fit, it is testing for constant variance. So if we see a random scatter of points, then there is constant variance. Although the pink line or red line seems like to show a pattern, but it is really minimal. So we can still conclude that we have constant variance, and even the linear model is appropriate, because if it wasn't, then we would see curvilinear or something else within this plot. Then the points are lying on this dotted line, and it's not deviating from it. So that shows that we have normal distribution in the residues. Then within this graph, we see that 0.11 and 7 and 6 are possible outliers. We can always test that. So the scale location function just looks at also constant variance. Then residual versus leverage shows us the values that are outliers, those values which are outside these two dotted lines, greater than these two dotted lines, they are called outliers. Even below those who are below these two dotted lines are also said to be outliers. So the ones we have 11, 6, and 4 are inside the graph. They are not outliers. Okay, any question? Okay, so I'm going to share R. Okay, so we have constructed the residual plots to check the assumptions, constant variance, normality, and we see that they are not violated. So we go ahead and use the model for prediction. Now we can also use sphere.test to test for normality of residues. So here we have sphere.test mod.2 $sign residues. So we want to test the residues, and when we run that, we get an output in the console. Let me just clean the console and run it again. When we run sphere.test, it gives us a W value of 0.949 and a P value of 0.6077. Now here, the null hypothesis is that the data is not normally distributed, and the alternative is that the data is, no, the null hypothesis is that the data is normally distributed, while the alternative says that the data is not normally distributed. So since our p-value is greater than 0.05, we have no evidence to reject the null and conclude the residuals are normally distributed. You can also test the response to find out whether it's normally distributed. So sphere.test egg p $ water uptake tests water uptake to see whether it's normally distributed. And it also gives us a higher p-value, indicating that the response water uptake is normally distributed. So that ends our simple linear regression. We are going into multiple regression. Any question in the chat before we continue? Residuals are normally distributed because the p-value is big. Okay. If there are no questions, let's go to multiple regression. We said yesterday, multiple regression is a relationship between the response and two or more independent variables. So the first thing we do before we run a regression is to find out the type of relationship we are dealing with using a scatter diagram. So still, we run our command to divide the window into a 2 by 2. Remember, instead of 2 by 2, you can put 1 by 1 to remove the division of 2 by 2. So if we run that and then run egg P, we are going to see a plot of all the data in egg P. We see water uptake takes the first line. The first column is water uptake, second column is food uptake, third column is egg P. So water uptake and food uptake, there is a strong positive linear relationship. If you look at the second graph on the first column, and then water uptake and egg P are strongly correlated, but not as strong as in food uptake. You see that the values are sparse. If you draw a line, it will go through the middle of the points, not in the points. So even the R is a little bit smaller, given that they are far away from each other. Then when we look at food uptake and egg P, there's also a linear relationship, which seems to be strong. Okay, so that is to show us that there is a linear relationship between water uptake, food, and also egg production. So we are going to run a regression analysis, and we are going to call the output model 3. We're using LM, which is linear model. We will write water uptake is a function of food uptake plus egg P, egg production, and the data is egg P. So let us run that and run summary model. So in the console, you will see the estimates of intercept, the slope for food uptake, and the slope for egg production. Okay. Okay. So remember that I say that if we want to interpret any of these estimates, you hold one constant and then estimate the other. So we can hold egg P constant, then interpret 3.03. So this implies that for every unit increment in food, water uptake increases by 3.0309. Then for egg production, for every egg produced, water uptake decreases by 3.256. So biologically, is that true? Now we go to biology and support our numbers that we produce. Is it true that when the chicken are laying eggs, they don't drink water? Maybe it is true, because when they are laying eggs, they can't really find time to eat, to drink water. So they will take less water. We need to do some biology there to support our statistics. And the p-value corresponding to these estimates show that there is a linear relationship between water uptake and food, and there is no linear relationship between water uptake and egg production. You can see the p-value is 0.3335. So we can also use AOV to produce an analysis of variance table, which is also testing for a linear relationship between water uptake, food uptake, and egg P. Okay. If you want to produce a confidence interval, you use the conf_int command and put in model 3, indicate your level, and run. It gives us confidence interval for the intercept and all the slopes. Okay. So if you want to construct residual plots, remember you have to run the model again. It's the same thing, but just remind the R that is the model you're using. And then when we do plot, we come up with the 4 plots for residual versus fits, QQ plot, scale plot, and the residual versus leverage. I told you that the assumptions under simple linear model still hold for multiple linear model. So we see that residuals versus fit shows us a random scatter of points. The QQ plot is testing for normality. The points are lying on that dotted line. And in this, since it's observed as random scatter of points, we conclude that the assumption of constant variance is not violated. We do not have any outliers in the residual versus leverage. The scale is also testing for constant variance. So we are good to go. We can now use the model for prediction. And then we can use this command with 1, 1 to remove the divisions in this panel where the plots are. We can use this brush to clean all plots constructed so far. So let's do that. And you say yes. Okay, we can also clean up that. So we are going into dealing with categorical variables. Any question? Okay. Any question? If there's no question, then we go to deal with categorical data. Okay. Okay, so our data is in a file called, if the assumptions are not okay, we use natural logarithm. We can transform our data either using natural logarithm, depending on the type of response. If it's continuous, you can use natural logarithm or 1 over y, so that we transform our data and stabilize the variance. Dr. Thomas, somebody has a problem with their R version. It cannot take up. It's not Gigi Scatter. You should install Gigi Plot 2. That is the package that has Gigi Scatter. Okay. Okay. Okay, let's continue. Now, when you have data, let's first of all import the data and talk about it. Okay. So if we go to uptake assign read.csv, then uptake, we are importing that data, and let's view the data. The data consists of a variable called species, and then time and uptake. So this is data about uptake of carbon dioxide. In getting this error, please help. Error in view, EGP could not find function view. You need to use capital view, uppercase view, not, so it is case sensitive. So yes, you should use that. Thank you. Materials of yesterday are in the same Google link. Okay, let me go ahead. So when we see our data in the console, it has a categorical variable with species Pinus S and Pinus P. Then you have time and uptake. This is uptake of carbon dioxide, time taken for the plants to take up carbon dioxide, and the species that is taking up carbon dioxide. So I want to find out, is there a linear relationship between uptake of carbon dioxide and time? Is the relationship similar for both species? Can we fit one single line, or we need parallel lines? That is what we are going to investigate here. Okay. So after importing, we are going to code our species. So there are two ways you can do this. You can either code Pinus C and Pinus P as 0 or 1, or you can just run an interaction. And when you run the interaction, it will show us that species is not significant. Species representing the different intercepts and the interaction representing the slopes. Okay, so when you have categorical variables, you can either fit a single line, just like we've been fitting, which is consisting of uptake as a function of time and species, or we can fit a parallel line where it is represented by the variable species. Or you can have an interaction of species and time to indicate that the result may have separate slopes, which will result into separate intercepts. separate slopes and intercept. So meaning you have different models for different species. So for us to be able to code species, we use this command. We have uptake $ species1, that is the name of the new variable you're creating. Assign if else uptake $ species is equal to Pinus SC. So that should be equal to 0, else 1. Meaning if you find any other thing apart from Pinus SC, call it 1. If you find Pinus SC, call it 0. So let's run that. This is coding and view. When you see the data in the RStudio, you see we have created a new variable called species1. Where there is Pinus C, it is 0. Where there is Pinus P, it is 1. Now, this is what we call an indicator variable or a dummy variable. It is just assigning numerical values to your categorical variable. So for ease of analysis, no meaning. Okay, so we can close that out. Okay, so now we plot our data using plot. Uptake is a function of time and data is uptake. So when we plot, we see that this is the data, the type of data. If you fit one line, some of the points will be far away from the other, but let's confirm that we need a single line, double line, etc. So we can now run a linear model of uptake as a function of time plus species. So if we find species significant, it will show us that the analysis requires different lines. The separate line is not appropriate. So let's run that. So when you look at the output where there are coefficients, I'm assuming that you are all with me. Are you with me or I'm talking to myself? Because I can't see any comment in the chat. Are we together? Are we moving together? Okay, we are moving together. So we've just run a model where we've put in species as a dummy variable, and that species represents different intercepts. So this species you see here will represent different intercepts. We are saying we can have the same slope, but the intercept is different. Is it true? So when we look at the output in the console, which we've just run, we have an output where there's coefficients. We see the intercept is minus 2.8, time is 0.20, and the corresponding probability is significant, less than 0.05. However, species 1 has a slope of minus 0.4 something, but it is non-significant. So when you find that it is non-significant, that shows you that we do not need to include separate what? Intercepts. It is telling us a single line is appropriate for our data. So how about if we decide no, let's see whether the interaction would be significant. So for us to run the interaction, we are going to write the command together. We are going to call it mod maybe 4, just to differentiate it with others. Let's assign AOV, that is an isovariance in bracket. In bracket, we have uptake. I hope you're following. Is a function of time. Make sure you follow me and also write is a function of time multiplied by species 1. So 1. My species is not correct. So hopefully you're following, so that species 1 and data, comma, data equals uptake. So you should have something like this. I'm going to highlight it in blue. You should have something like mod 4, assign AOV, uptake, a function of time times species 1. This is when I'm saying no. Maybe the interaction is significant. Jude, species is categorical, true, but we coded it as 1 or 0 and formulated a new variable called species 1. So we've changed it to numerical. Okay. Okay. So I assume everybody has written this. I'm going to run. So if I run that and it's okay, I print mod 4. Mod 4. Since mod 4 just gives me summary, I mean only intercept, I'm going to write summary in bracket mod 4. So that will give me an output to see whether my interaction is significant. So let me run that. So let's go to the output. Does everybody have an output for AOV uptake as a function of time times species 1? Let me see in the chat. Do you have that? Why am I doing that? Is to check whether we can have separate slopes. To check whether we can have. So we see that the space time is significant. However, species 1 is non-significant. That represents the separate intercepts. Now, time times species 1 represents separate slopes, is also non-significant. So this is confirming that for our data, we don't need to have separate lines. We only need a single line for the data. So if you have species SC and species SP, one model is enough. We don't need to separate the models. Okay? Is that okay? Any question before I move on to the other one? So that's it about categorical variables. You can create more than one dummy variable. So species 1 is a dummy variable or indicator variable. You can create more than one depending on the number of categories you have under your categorical variable. If there are 3, you need 2 dummy variables. If there are 4, you need 3 dummy variables. It's M minus 1, where M represents the groups under the categorical variable. Kindly repeat what you have just said about what we are checking. Okay, I have said the analysis you have in the console. First of all, we tested whether we needed separate intercepts by creating dummy variable called species 1. It ended up to be non-significant. We said, no, let's test whether we need separate slopes. We put in an interaction. The interaction represents separate slopes. So when we run the analysis, we see that uptake and time are significantly linear related because the p-value is smaller than 0.05. However, species 1, which represents separate intercept, is non-significant, meaning we don't need it in the model. And species times time, non-significant, meaning we don't need separate slopes. So we don't need separate slopes, we don't need separate intercept, only a single line is appropriate. Okay, I assume that is okay now. Today I also got some data, but I think I'll not go through it. It gave me the same result. Let's go to polynomial regression. Now, yesterday I didn't talk about polynomial regression, but sometimes you have data, instead of showing a linear relationship, it shows a curvature. So let us import polyreg from our data. So and we are calling it hard. So that data consists of tensile strength of paper and hardwood concentration of pulp. When we are making paper, we need pulp. Pulp, that is wood which has been smashed into smaller pieces, called pulp. So the amount of wood pulp you put in determines the strength of paper until a certain level, within which, whether you add or not, the strength still remains the same. And then you take off that level and recommend it to whoever is making paper that you should have maybe 6.5 as the maximum for you to get the greatest strength, which strength is resistant to water, etc. So that is the data set. He says, I want to assess whether slopes differ based on rivers. Which one is better between these? ln log. You use AOV instead of LM. Use AOV as the function instead of LM. So in front of this, you need to use AOV, which gives you an analysis of variance. And it's going to analyze your data as if it's experimental, but you are running a linear regression model. Okay, hopefully that is okay. So let us plot our data. Our data is called HART. Column name gives you the names of the data set, so you write them correctly. Then we plot tensile strength as a function of hardwood. And we see that, let me close out this chart first and stop sharing. I want to share this so that you can see what I'm talking about. I want to share the output of the, oh, okay. Zoom. Okay, let me go back. Let me just close out all graphs and yes. I'm going to run the plot again and then zoom. There must be another one which is open. Okay, anyway, just look into your plot section. You'll see this curvature here. So our data shows that's not linear, but it's curved. Okay. And if we ignore this and fit a linear regression, let us see what happens. You've observed in your scatter diagram that actually this relationship is not linear but has a curvature. It could be quadratic or it could be cubic relationship. But let us pretend like we have not seen that and run a linear model. So the second part is to run a linear model. So we call it mod 1, and LM is for linear model, tensile strength as a function of hardwood. Data is hardwood.
Are you sharing your screen?
Oh, sorry, I had forgot.
Okay.
Screen off, sorry. Thank you about that. Thank you. Sorry about that. Okay, so what I was saying that if we look at the plot, it shows either a quadratic or a cubic relationship between tensile strength and hardwood. So then But we want to pretend like most of us researchers, once we have data and we are supposed to run a linear relationship, we don't even draw the scatter diagram. We go and analyze the data using linear regression. So let's do that. Run a linear regression of tensile strength versus hardwood and see what happens when you specify a wrong model for the data. So when you run that, and summary, the linear model seems to be adequate, but only explains 30% of the variability in tensile strength, meaning you have other factors that need to be added into the model. That is the first part. I hope all of you can see that. Then let us plot the residual plots to see whether they're okay. When you look at the residual, the first plot is residual versus fits. I'm assuming that you all have these residuals now. Is it true in the chart? Do you have the residuals? I only see one person, 2, 3. I need like 1,000 of yeses. Okay. Okay, thank you, thank you. Great. Okay, so if you look at the residual plots you have, we see that residual versus fit has a pattern. The residuals are increasing with fitted values, indicating 1, there's no constant variance. 2, the linear model is not adequate. You see they are drawing a curve within these residual values. Okay? When we go to the QQ plot, for it showing that the data is normally distributed, although it has some bit of deviation down here, showing a bit of, there is a bit of skewness in it. Some values are on the line, the straight line, but others are off the line. So the data might be skewed according to the QQ residual plot. Even the scale location still showing us the linear model is not adequate. There is a curvature here which needs to be taken care of. The Cook's D, the residual versus leverage, confirming that the values that are indicated like 19, 1, 18 are not outliers because they are not outside the dotted line, below the dotted line or above the dotted line. Okay, so we've seen that we need to take into account this curve here. So what we are going to do is to create a variable that represents that curvature. So we'll start with a quadratic. So we have hardwood, you're creating a variable where hardwood concentration is squared. So we have hardwood $, the new variable, assign hardwood in bracket raised to 2. So here, this helps us to create a new variable in hardwood which is squared. So you can investigate and find out. If you square 1 under hardwood X, you get 1. If you square 1.5, you get 2.5. So this is just to check whether you've done something correct. I hope you've seen that this is now a correct variable. Let's now go to run a quadratic model. Okay. So mode 2, we run a linear model as tensile strength is a function of hardwood plus this hardwood squared. The data is hardwood. So when you run that, okay, so let's look at the output. The coefficients show us that concentration X, which represents linear bit, is significant. Hardwood cont, which represents the quadratic, is also significant. The amount of variability explained now increases from 30 to 90.8%. If we look at R squared adjust, it is 0.97. So you can see by adding a quadratic term in the model, you're explaining more variability in tensile strength. Now, since there is a significant quadratic relationship between tensile strength and hardwood concentration. We know that we cannot model our data just as a linear model, but we use polynomial regression where we include powers on the independent variable. Let's look at the residual plots. Hopefully you remember these residual plots which we had before. So we divide and then draw our residual plots. These are the new ones. Okay, there's still some bit of curvature, but now the points are spread out. Probably we need to add a cubic to make them more. So you can go ahead and keep investigating the data, but it has improved from what it was to what we have here. And even the data is tending to be more linear than what we saw before. Probably we can add a cubic if you want, but for now, since you have other things to run, you can do that later in the evening. Transform x to x cube and run and see what happens to the residual plots. I've done that and the residual plots appear better than when you have a quadratic. So this is about polynomial regression. And if there's no question, I am going into model building with a break. Do you need a break now? Let me see in the chat. In case of, oh, I didn't see that question, but okay, they say they need a break. So break of 10 minutes, come back at 3:38. We do model building, and that will take us, I think, 1 hour only. And then I can allow my colleague to come in and give us an introduction of what she has, which will take us also until tomorrow. So model building could take 30 minutes, depending on how fast we will do it. Okay, so let's go and have a break. Thank you for listening. There was a question there which I missed, so you can post it back. It's ggplot 2, add 2 in the installation, and it will install. Yes, you can explain how you move from linear to polynomial using the scatter plots. You need to do that in the analysis actually in the results section. You can explain why you're going to polynomial because the scatter diagrams are showing you as a curvilinear relationship.
Hey, Gabriel is saying I installed ggplot2, but when I run the gg scatter, it said the function. So you probably need to call the library ggplot. Use the command library ggplot2 then before you can use it. Remember, after installing, every time you need to be able to call the package so that you can use any function within the package.
Okay. Let me
Maybe can you allow Abraa Agas to share the screen? It's saying not finding.
Let
It's
them
not
raise their
importing the
hand.
data.
Please raise your hands
Abraa.
so that we upgrade you.
Oh, boy.
Okay, so what is the problem? You can tell us.
I think he's having challenge with getting the data or what. I'll let him try and we see him or her. I don't know.
Okay. Mm-hmm.
Yeah, but you already called I thought you already called the data, no? By bringing it the other side. I don't understand.
You need to set the session, you need to set the working directorate. Because you've called it into R, yes, set the working where the data has been saved. Okay, then run and we see. Run hardwood. So that means that directorate, we don't find that data there. You need to download the data.
Can you click on the file near the plot? There is where it is written file, where the plot is. No.
So that one has run, the data is there. Okay, run that too. Yeah, that one is okay. That one is fine. It's only the egg which is lacking in the directorate. You didn't download it, maybe. Okay. So do you still have a problem? I can see this one running. So even the first one can be handled the same way. Okay. Okay, you can stop sharing. What is ggplot2? It is a package under R which allows us to construct and manipulate plots, draw plots. Okay. You install ggplot2 as a package. Use the install.packages in bracket ggplot2 in inverted commas and run. After that, call it using library in bracket ggplot2 and run. Then it will run. Okay. Cube is definitely much better. Oh, great. Thank you, Henry, for trying it out. I also tried it out and Cubic was definitely much better, but I wanted you guys also to do something. Okay, good. Let us share. We are now going to deal with I'm just going to do a practical for model building. So you open it. Something went wrong.
Somebody is saying you can't find the material for today.
Oh.
Was new material added or it was the one of yesterday?
No, yesterday. I haven't added anything.
Yeah, so it should be the one of yesterday, NS.
So there is a script called model building F in the Google Drive in the yesterday's material. So please download that and let's use that. Okay. So instead of going through theory and practical because of time, let's go straight to practicals and explain the same things as we go along. So the first thing we do as we open a script, we load the packages. So we load these packages. And once they are loaded, there is a package which I want you to install. It's called Faraway. So install that. I'll not install because I've already installed it. That consists, okay, yes. Faraway, the following object masked by, that's okay. So this is where our data we want to use is. So install package Faraway, then run the library. So I'll give you 2 minutes to do that. We cannot see the screen. Oh, okay, sorry. Stop sharing. I'll share again. Can you hear me? Is the screen still blank? Yes. Oh, the screen is blank. Okay, let me stop sharing and share again. I'm told the screen is blank. So let me just close this.
No, it was, I think you closed it before. It was about to come.
Oh, let me share. My internet is a bit unstable. So let's wait. Is it there now?
Okay, there it is.
Okay, thank you. So anybody who doesn't see the screen? Okay. So we are going to use it for model building. What is model
Whoever
building?
doesn't see the screen must be a sinner.
Not really. Okay. So sometimes we have so many variables that are related to the response that we assume affect the response. And we need to select a few that explain most of the variation in the response. So we use a method called model building or variable selection. Under model building, we have 3 methods. There is stepwise, backward elimination, and forward selection. We also have another method called best subset. So those are the methods we are going to see in this practical. I will explain each method as we go on. So if you've opened the script, load the packages just like I've done. You load these packages, highlight them and run. And this package called Faraway, if you don't have it, load it again. Install it. Then you call it using library. After that, we need to call the dataset from R. R has archived data which we are going to use. And when we do data in brackets, when you write that command, it gives us a list of variables indicating the data set we are likely to be interested in. So if you want to have some examples. There are many experimental, all sorts of examples are here you can use. So let's close that out. Then if you write data in bracket, the data set you want, it now brings a data set in the environment. And then you want to create a data frame from that data. So we are calling it state data, assigned data frame. And the data is state.x77. Read the row names as from the data. So we run that and run. And you see now we have a data set. So this data consists of information from life expectancy of people in the US, different states, and would like to model life expectancy as a function of all those variables: population, income, illiteracy, murder, high school graduate, frost, and area. So all those somehow, if you read about literature, could affect life expectancy. But we cannot have all of them in the model. It will be too crowded. To be very expensive for you to collect all those variables. So we need to select some that are okay. So you can run some summary statistics to see the income, the highest income, the lowest, the median, to see the person who has highest level of education. We can run column names to see which names are we going to write. We can also run STR to see the structure of the data. All of them have been specified as numerical. So we are good to go now. Are we all at this stage? Let me see in the chat. I'm lost. Where is the data we are currently looking at? Follow the script. Follow the script, you see the data. Please, can you repeat? Where is far away? Okay, I'm going to repeat. I have a question. Have you installed the package called Faraway in the chat? Let me see. Have you installed a package called Faraway? Using install.packages in bracket Faraway. Do you have that? Okay, good. Then have you called the package using the library command? Can I see in the chat if you've called the package using library command to make it active? The data set is within R, but we have to have that package. Okay, if that is the case, then I'm closing. So for us to see a list of data set in R, we use data in bracket. Once you write that and run, we see a list of packages. You can see very many. This one is about carbon dioxide uptake in grass. We have chicken weight versus age of chicks on different diets. Everything is here. You can use them for your practice. So let's close that out. Data in bracket state tells you that our data we are interested in is called state. So when you run, you will see in the environment window telling you that state data has 50 observations and 8 variables. Now, we want to create a data frame for our state data. So we are calling it state data, assign the data frame and of state.x77, and the row names should be just like in the description of state.abb. So we run that and then run state. So it gives you the data. So are we all there in the chat? Are we at that stage where you're viewing the data? I'm downloading far away, okay. Are we all having the data in the console? Have you seen the data? So that data is about life expectancy as a function of those many variables, but we want to select only a few that explain most of the variability in life expectancy. Okay? Okay, that is good. So you can use summary statistics to show the average income, the average population, etc. So summary statistics, the next command, it's to show some descriptive stat. So there you can see the population, the minimum population, the maximum population, the median population, income, you can see the income of people, literacy. So you can go ahead and do a lot of things with this data, okay? You also check the column names, how they are written. Check the structure of the data. They are all numerical. Now we have no problem. Let's go ahead and run our regression. So the first step we do is to run a regression with all the variables in the data. So we are going to call that output G, assign a linear model, life.x is the response, is a function, dot, a comma, meaning run everything in the data called state data. So let's run that. And then summary. So when you run that line and then summary of G, that is the model. G consists of the output for this line here, line 30. When we look down in our console, we see the intercept and the slopes corresponding to the independent variables. We also see the p-values. If you look through the p-values, we see murder is significant, high school graduate is significant, the rest are non-significant at 5% because their p-values are greater than 0.05. So let's go ahead, but the amount of variability explained is 73, or R squared at just is 69.22. So we need to add more variables to explain, or we need to eliminate those that are, if affecting the others because of correlation. I have not run a scatter diagram, but that's what you should start with. Because of time, I just went into. Now we can use ordinary square, which is OLS, or we can use AIC, which is Akaike Information Criteria. So ordinary square is the normal program for regression. Akaike is a function or a statistic that you use to assess different models. The smaller the AIC value, the better. The AIC compares a model with intercept alone with the final model and gives you a value. So if that value is small compared to the model with intercept, then the final model is better than the model with intercept. So forward selection. In forward selection, the program starts as if we have only a model with an intercept. So we start with y is equal to beta naught, which is the intercept. Then we keep adding variables that are highly correlated with the response, one at a time, and use a criteria that the probability for variables to enter the model is 0.05. So any variable with a probability less than 0.05 is allowed into the model. So it continues like that until all the variables in the model have p-values less than 0.05. That is the forward selection. I repeat, it starts with a model with the intercept alone, keeps adding variables which are highly correlated with the response, but after adding them, it assesses whether the p-value of the added variable is less than 0.05. That's why you see here, forward is the name of the results, and then assign OLS underscore step underscore forward selection. P is the criteria, and the criteria P to enter is 0.05. So let's run that. And let's see the output. So I want us to see the output. When executing console. Okay. Some error here. Okay, so it is still running. Interrupt and stop it. Oh. Okay. Somebody has raised up their hand, so maybe they give them an opportunity to speak. I'm going to stop sharing and open my R again because R has in the meantime, Thomas, can you help me and listen to the gentleman with his hand up? I close my R. Let me just log off and log in again. R has refused to respond. Okay. Thomas, do you hear me?
Yes, I've already allowed him to talk.
Okay, you can talk.
So maybe he can unmute himself or herself and talk. Yangaza, we can see your Yangaza, please, you can talk, you can ask or comment.
Arthur, I'm going to switch off. Arthur?
Yes, please. Prof.
Arthur?
Yes, please, I can hear you,
I'm
Prof.
going to switch off. I'm going to log off and log in again. My R
Okay.
has stopped working.
Oh, thank you.
Yes, so let Thomas help me or Helen to help that gentleman. So I come back in 2 minutes.
Okay.
Okay, thank you.
Yangaza, go ahead with your question. Yangaza, are you with us? We can see your hand is up. Oh, maybe it was just a Yangaza. I think it was by mistake.
Could there be any other person with a question or any challenge that we can look at right now as Prof gets back? Maybe it's within R, there's something that might be a little that you didn't understand very well, or a certain line didn't run, or a package, we can help.
Colleagues, please, is there any question, as Dr. Henry said? You can raise your hand. I think there are some questions in the chat.
Yes, but the ones that I'm seeing in the chat are part of what Prof was trying to run to ensure that they can follow very well.
All right, Doctor.
For example, Adrian has an error in OLS, step forward, PG, penta equal to 0.05 could not find function or else step forward p. Most of the time, if you find such an error, like could not find this particular function, not necessarily this one that you're having, we've been seeing that such comments have been coming through. One thing that you have to check is to see that did you run the required packages, especially usually at the beginning of the R script, okay? Because like we mentioned in the beginning, that all these packages that we tend to install, they have already inbuilt functions that support to run the commands that we use. And you just need to know that I'm going to perform such a test, so what package do I need? So when we are going into model building, the package that Prof was talking about that everyone has to install, you need it. Otherwise, if you don't install it, then it implies that it won't be able to function. The other commands that you're going to be having throughout the process, it implies that they will not run. All right. So I think, Adrian, you can check again. Did you install the required package? If so, did you load it using the library? Because within the library, the moment you use the library command, then it implies that the functions that are within that package, then they can be able to be executed. So that's how you can solve that particular part. I can check in the yesterday's folder again on model building, and then I can see the package that you need to have installed that you need to use. Yes, there is a package that Prof was saying that install package far away. All right, that is the package that supports model building. So if it is not right, if you didn't install it, then it implies that that's where the problem is coming from. And then after installing, ensure that you load it using the library command. That is how you're going to sort that problem, and it applies to whoever comes up with such a problem. Because most of the time, when you're going to use R, you have to ensure that the packages are installed. But the moment you have those packages installed, each time you open your R script, you have to load those libraries such that R gets to know that you want to use them. I think you can try that, and then you can get back to us if it has solved the problem or not yet. How many times do we have to run where using the forward step? How do you determine the number of times? It's not an issue, because there are criteria that you need when you're determining the right model, whether you've used forward or you've used a backward or a step forward. All right. So with that one, remember, she was talking about the AIC. So with the AIC, when you check through these particular models, when you're trying to compare the three of them, the one that gives you the lowest value, okay, as you keep repeating, as the number of the variables keep on reducing, you of course the R will tell you that no, when you include this one, it increases the AI. When you remove this one, it reduces the AI. And then it is from there that you can come up with a conclusion that depending on the three approaches that I've applied, which one has the lowest AIC. And then you can pick up from that. Sometimes there are some other things that you can look at, like the R squared. And then if you don't consider the R squared, depending on there are three basic criteria that you really depend on to say that of these models, then I can be able to take up this particular model. But usually the AIC is the best that you can use to determine that. I have an error in this install.packages ggplot2. error in install package object that not found. Sometimes such a challenge can come in, usually when you have poor internet, but most of the time you find that ggplot2, sometimes it is installed in other packages. For example, packages like tidyverse, and then if it's not tidyverse, then it is dplyr. So when you install those packages first, when you look at the script that you're having, professor's script, before installing the far away, there are some libraries you have up there. I don't know if you've installed them already. Like you have tidyverse, you have learn-r dplyr, and then the ggpr. Then later you can install the ggplot2, because like we said that these packages are nested. So sometimes you find that when you install a package where this other one you want that is nested in, then it implies that you can easily run that library. So still you need to check again and see whether you were able to install that ggplot properly. And most of the time, remember how the command is. When you install .packages, the ggplot2 has to be in double quotes. Otherwise, if you don't put it double quotes, you're going to come up with an error. Okay, when you put it in the double quotes, then that it implies that it will be very okay for you to be able to solve that. Let me try to let me see if I can share a Profi script on model building, and then I can show you. Okay. I hope you're seeing the screen. I was mentioning that in case you fail to see the ggplot, there are some already packages that could be then nested within the ggplot. And the moment you install them, you can easily rectify where the problem is. So most of the time, it's about practice. When as you keep on working, you see that you can easily rectify most of the stuff. So if somebody is saying that you are not seeing the ggplot, all right, can you try to first install tidyverse? Yes, we tied that tidyverse supports data manipulation, and sometimes these packages, the big packages like tidyverse, all these packages are nested in there. So if you have the tidyverse for you, if you install the package tidyverse, then now you can try to install the ggplot. You can try to load the library ggplot and see if that one works out. Okay. Benford is saying now it works. That is good. Screen was not showing. Oh, really? Let me share again. How about now? Can you see my screen? Can you see my screen now? When you see the script, I'm sharing the model building f.r script, okay? the script that prof was using, and I was saying that somebody saying that yeah, it has worked. So I'm just referring to some other people who are saying that they haven't yet succeeded with installing the ggplot. So the point is, can you try to fast load? If the internet issue is ruled out, like no, my internet is strong and stable, then it implies that maybe you need to install a different package where that particular package that you need is nested. And most of the time, like I mentioned, when you're using the tidyverse, it's a package for data manipulation and does a lot of things when it comes to analysis. And ggplot is nested within tidyverse. So if you install tidyverse, after that, try to install the ggplot too and see if it works. But tidyverse first, then use the ggplot. I think that would rectify that. I did successfully install ggplot too, and I ran the library, but I still have a problem in running the ggScatter plot. Okay, having installed the ggplot too, because it's also it supports in data visualization. All right, can you now try to install the ggScatter command and see?
Thank you, Dr. Helen.
Oh,
My
okay.
R got a problem.
Mm.
So I don't know. Maybe let me try to see whether it can work. If it doesn't work, then you will open your R and put it up.
Okay, let me stop sharing.
Okay. No, Dr. Helen, I think, can you open your script, my R script from your side, and we see that it will work? If it doesn't work, then I can continue tomorrow and let you go on. Can you hear me?
Sure, I do.
Okay, open the model building script from your side.
Let me first install
Okay.
far away because I'd not
Okay.
done so. Then we
Mm.
can continue from there.
Okay.
As we are waiting for the package to install, maybe some of you might be having challenges on how to install packages. Remember, we say that use the install.library, but since like R is an open source, it has to go to the R crane online to pick that particular package you want. So you need to give it some time for it to install. And then after that, you load it and continue with what you want to do. I'm hoping it won't take forever.
If it does, then I will let you go on, then I can finish that tomorrow. Tomorrow after you. I can't see it taking forever.
It's now installing far away. Yes. There are some other packages it's installing, but all is well.
Okay. I don't know what happened to my R Studio. Something I have to uninstall and reinstall, which will take a bit of some time.
I've gotten far away. I can terminate it now or I wait.
No, leave it just in case it doesn't again bring problems for us. Yeah. I think it has like a few minutes to be done. Or you go ahead and explain the model building bit, if you don't mind. I can chip in wherever you want. Open R, Beto error.
I think the main package is far away, not so? I'm going to stop this and then
There are also other packages. Do you have them? The ones that you clicked the yellow to install? Gigi BU also is installing. I think. Yeah, it's installing some of the packages you need.
It's taking forever. Okay, let's just give it some little time. Maybe, Prof, just for a discussion part of it, there was a
Yes.
question in the chat that was saying that how do you determine within like you've got the three types, the forward,
Yes.
the backward, and then the stepwise, that how do you tell
Yes.
the best model to use?
There are criteria. There are about 5 or 6 criteria. We look at the R squared adjust. The one with the highest R square adjust is the model we choose. So we combine all those criteria. We look at the mean square error if it is small. So if model 1 has a high R squared adjust, it has a small mean square, it has press. Press statistics helps us to predict, to show that the model has good predictor ability qualities. So if it is small, then that model is good. If the mul CP, this is a statistic whose value is equal to the number of parameters in the model. So if that CP is equal to the number of parameters in the model is good. We look at AIC, Archaic information criteria. If it is small, then that model is good. So those 5 criteria, we put them up against all models and compare and choose one which has all those ones combined.
Okay. Sounds great.
Yes.
I think
also we have to make sure that the X variables, the independent variables are significant in all those models and they are not correlated. If they are correlated, then we have to run an analysis to show the variance inflation factor. How are they affecting the parameters? If the variance inflation factor is high, for any of the variables, then we can remove it from the model and remain with a simpler model whose independent variables are not correlated. Because remember, independence was one of the assumptions we made under multiple regression. So while we are selecting a model, we shouldn't violate any of those assumptions.
One was saying that can we put them in the chat, but they are within this particular script we are using, not so.
Even in the notes that I sent, they have those things written in the PowerPoint. Okay, so you can run that data.
Okay, I ran line 20.
Yes, run line 20. And then close it. Just watch the data sets in R. Don't close that one. Close R data sets.
Okay. So you pick the one for the state?
Yes. So then we run the second one and run to get the data. So we have the data. We have we had run the summary statistics. We also had run the column names and the structure of the data was okay. Then we ran the general regression model with all independent variables and got a summary. And in the summary, we found that only 2 variables were significant. That was murder and high school graduate. So we want to go to the forward selection. So I was explaining about forward selection. Under forward selection, the method starts with the model with intercept alone. And then the variable which is highly correlated with the response is added into the model and assessed using the criteria P to enter is equal to 0.05. So the probability of the entered variable should be less than 0.05 for it to qualify to enter the model. So the process continues like that until all the variables in the model have p-values less than 0.05. So you can run that line 35 and print the output. So let's go to the output, to the top. Continue up. Continue.
The first results, these ones had regression. You started with the, sorry?
It's still going on up. You continue up. You will see where it starts from. There, it starts from here. So the first part shows you the, no, there we are, okay. Stop there. We had already discussed. You start where the is. There.
The model.
Good, there, don't go ahead. Right there. So the first part, that box you see which has stepwise summary, it is showing you that in the first step, the program started with a base model with the interceptor alone. And the AIC was 174.329. The R squared adjust is 0, so no variance, no variability explained in the response because it's an intercept anyway. Then we added murder. So murder is highly correlated with life expectancy. It is added in the model. When it's added in the model, its AIC becomes 129.2. We go ahead, look at R squared adjust is 0.6. So 60% of the variation in life expectancy has been explained by murder, indicating that when people are murdered in those cities, then their life expectancy is cut short. So the second variable added was high school graduate. And when they add, the AIC lowers again to 123.96. And R squared also adjusts, becomes 64.85. Then they add frost, AIC decreases. Remember, we are comparing AIC with the base model. So it decreases to 117. The R squared adjust increases to 0.6939. Then they added population, AIC decreases, and R squared adjust is 71.257. So the output ends there. The program ends, and its model consists of life expectancy, is a function of murder, high school graduate, frost, and population. So below here, we have the model summary. It is giving you the residual mean square. It's giving you the mean square error, coefficient of variation, AIC and BSC. Even the BSC, which is defined as Swarth's Bayesian criteria, should be small for the model to be good. So this final model has adjusted R squared of 71.3%, predicted residual square of 66.4, and mean absolute error of 57.0. So that's what they are saying here. So let's go to the ANOVA table. Can you scroll down? Helen?
Yes,
Can you scroll down?
I have. You can't see it?
No.
You can't see the ANOVA table?
No. It's below.
Are you seeing where I'm highlighting?
Yes, now I can see. Okay, there we go. Okay, we have analysis of variance table there. I have seen it now, showing us that overall, there is a significant linear relationship between life expectancy and all the chosen independent variables, given that the p-value of 0.000 is less than 0.05. Then under here, parameter estimates, it gives you beta represents the intercept and slopes for each independent variable and the corresponding significance level. Okay? So that is forward selection using ordinary square. So let's go and look at forward selection using AIC. We get the same model, so you can run that and run the model. So it takes some time, so we give it time to. Okay. So let's go and see our output right from the beginning. Yes, from the beginning. Continue. Continue. Continue.
There.
Continue. Okay. There, yes. So this AIC, it gives you output in step by step, showing you what has been added. It's AIC. It's just similar to forward selection with ordinary square, only that here the criteria they are using to add the variables is called AIC. So here it shows you that we have all these 7 variables, independent variables. Intercept. IC is 174, just like before. Then go down. So from there, it adds the variable which is highly correlated, which is murder. Again, you can see that the same AIC we got is here. So go down again. Then they add another highly correlated variable. Can we go down? Which is a high school graduate. So when we have life expectancy, murder, high school graduate, so here we have murder, high school graduate, and frost. Its IC is 119, and also we have a corresponding R squared adjust. Then we add population, just like in the above model we had for forward selection. So the results are the same. So you can choose whichever method you want to use, forward selection with ordinary square or forward selection with AIC. So we get the same model. The rest of the output is similar to forward selection. Can we go to the script, please? So let's see backward selection. Forward is done, yes. So in backward selection, you can run the model as I explained. It starts with a full model with all the independent variables in the model. It goes on dropping those which are non-significant using the criteria P to remove is equal to 0.05. So this one is the opposite of forward selection. It goes on dropping, dropping, dropping. So let's run the first output, that one. Yes, that one. And run the output. You run back.p, you run that one. Okay, let's see the output.
I continue up.
Go ahead. Yes. Okay, there. So we have the candidate terms, there are 7, that's okay. So you can see step 1, it has a model with all the 7 square, they use R squared as their criteria and a P to enter. So the initial step has all the 7 variables. The second step, they remove the one which is non-significant and they are highlighting its area, so it is removed. They remove illiteracy, go ahead, they remove income, then they say no more variables to remove. So the variables removed are area, illiteracy, and income. So back.p gives you the final model. Let's go down. So the final model produced, go down. It has population, murder, high school graduate, and first. It is similar to forward selection. Even AIC gives you the same model. So because of time, let's go to stepwise. Let's go to stepwise. Go to yes. So stepwise using ordinary square, let's see what it gives us. So you run and then run the both.p. So under stepwise, what happens is that it combines both forward and backward selection. It starts like forward selection, but as variables are entered into the model, they are also assessed for being dropped out of the model. So it combines both forward and backward selection. They are working hand in hand. You enter variable, it's assessed for being removed. You enter variable, it's assessed for being removed.
Can we allow Zanele to show our screen or our screen? It seems to be struggling with something.
Okay. Helen, you can, okay, stop, okay.
Raise your hand up so that they can promote you and you share your screen and we see what's going on.
Doctor, I've seen it, I can see here 3 hands. Let me promote the fact.
Okay.
Sid, can you talk? Zanele, are you with us?
Yes.
Please
Yes,
go ahead.
I don't have access to sharing my screen. Can you allow me permission? Hello?
Shouldn't be an option of sharing the screen. Don't you see where you raise your hand next to it, there must be a share, the green box.
There's no green box. There's just chat, Q&A, and show captions. Just those three.
Where this your hand there is not all you have where there are options.
No.
Yeah, maybe you can get from options.
Do we allow multiple sharing?
Can you, is anybody else sharing? I am not sharing.
Okay, let her try again and we see. Because if it is not there, then I don't understand exactly what's going on.
It's still not there.
That we finish, then we can handle her problem later.
Okay.
Maybe I can see another hand. There's another hand here. Dantan, please, can you talk? Dantan, can you hear us? Unmute yourself. Yes, please. Unmute. Hello? I think also we can handle her later. Or him, because cannot talk. You cannot hear him.
Prof, can I share again?
Yes.
Yes, try.
Share. Okay. So we're talking about the output for forward selection, and we're saying that, stepwise. Stepwise combines both forward and backward selection, but it starts as if it's forward selection with a base model. Then it keeps adding variables which are highly correlated, but as they enter the model, they are also assessed for being removed using P to remove of 0.05. Remember, P to enter is also 0.05. So MADA enters into the model with only the intercept. As it enters, it is assessed for being removed when high school graduate enters the model. So just like that. Also, as Frost enters, high school graduate is being assessed for being removed. If it is found to be less than 0.05, it's left in the model. As population enters, all the other variables, MADA, high school, Frost, are also being assessed for being removed at P remove of 0.05. So the process stops when the model, the final model, has all variables less than 0.05. So we see that even stepwise has given us the same model. It has MADA, high school graduate, Frost. You can go ahead. Yeah, move the cursor. Frost and population. So go ahead. So for all our three methods, we compare for the different models. The one with the smaller mean square error is chosen. We look at the AIC. The one with the smaller AIC is chosen. We look at R squared adjust. The one with the smallest R squared adjust is, the highest R squared adjust is chosen. The one with the smallest predicted residual square is chosen because predicted means that the difference between observed values and predicted values should be small. The predicted values and observed values should be close to each other for the model to be good, to be used for prediction. So those are the criteria you use for selecting among the different criteria that we've chosen. We've used backward, forward, and stepwise selection. The last one is called best subset. Let's go to the out. It's called best subset. We can go straight. So in your meantime, in your free time, you can, it's called all best subset. You can run that and run all, then run all. Then let's look at the output. You can make your screen larger, extend it to the side of the plot section, yes. So go up, that one, there. So this method here is going to look at all possible subsets of the independent variables. It starts with a model with only one independent variable. It goes to 2 independent variables, 3 independent variables, 4, 5, 6, until you have 7 of them. So it now gives you the criteria. I think it's using R squared. So you look at R squared to choose which model has a beta. So you can see it has R squared. It has also mal CP, yeah? The high school graduate and Frost. So we go to the model which was given by, go up, Helen, Dr. Helen, go up. Dr. Helen, can we go
Yes,
up?
I'm scrolling, but we are
Oh,
going back to the
myself.
one. I thought it would bring all of them on the same page. Come again.
Okay, yeah. Scroll down. Can you hear me?
Yes.
Where there is 4, okay, there are 4. So we can see population. We want one which we've already chosen is what I was looking for. Population, murder, high school graduate, and Frost. That is the one which I wanted to look at and compare with others. I don't know where it is.
It is here.
There it is.
Population.
You can highlight it.
Yeah.
So if you look at where we have 3 and 4, this particular model which came out of the other 3 has the highest R squared, and it's model 80.
Yeah.
So let's go down and look for model 80 and look at its AIC, mal CP and R squared adjust, model 80. You can scroll down. Model 80. Model 80 has R squared adjust of 71.2. It has mal CP of 2, which is quite good. So even when we look at the best subset, it gives us the same model as the one which has the best criteria among all these we are comparing with. So once you decide on the most appropriate model, you go and test the sums of squares and also test the assumptions, sorry. Once the assumptions are valid, then we are good to go with our model to do prediction. We take that as our final model. So when you're presenting your results in an article or your project, you only present the criteria and the coefficients for each independent variable, and on this you make a superscript to be a star indicating that variable is significant. *1 means it's significant as 0.05, *2 significant as 0.01, like that. So you keep showing that this variable is significant using the stars. You don't need to put the p-values in the table. You only put the coefficients for each independent variable, and also the R, just the AIC, the mean square error. You can now start doing prediction.
Prof, sometimes you break off and we don't hear some things that you're saying.
I think it's the internet, or it's my computer. I can see it has turned black somewhere. It has blue and black screen, so I don't know what is happening to it. Anyway, hopefully it is alive. Okay. Generally, so here it is tired, yes. Here, when we see P, LM, life expectancy, the function of the 4, we are now running our final model, then run the residual. So let's run the final model. You can, Helen, run the line 75. You've run it? Helen? Dr. Helen? Okay, I can see you've gone off. Mhm. Okay, so what is happening is that the last part.
She's trying to get back. I think she
Yeah,
got off.
So we just summarize since we are about to finish. We have only 11 minutes. So what I was saying is that I can't show my screen of R Studio. It got corrupted and went off. That's why I couldn't show it. So I'm saying that once you have the final model, you run it again, check the assumptions. If the assumptions are not violated, then you go ahead and do prediction. So then you can write around. You can write around the model.
One of the students can share the script, maybe share the one who is running it successfully.
Yes, if one has run a successful script, you can share and we use that to finish in the next 10 minutes.
Yes, Judith, go ahead. You can share.
Yes.
Judith, are you preparing to share?
Somebody who has a successful script, raise your hand and you're promoted to share.
Mukunga, are you able to share? I've already promoted you. Maybe they are facing the same challenge which the previous one is facing.
I don't see the pop-up, the icon for sharing.
But are you using the Zoom link which we have shared? Is it the same?
Yeah, I don't know. I can be able to speak.
Bottom
I'm
line
unmuted,
down.
but I cannot share the screen. There is no icon for sharing the screen.
Try to check where it's written more. Maybe you can find more settings.
Okay, let me go to settings.
Try to check. Maybe.
No. There is nothing like sharing.
Okay, I think we can stop here.
Yeah.
You can go and do the rest of the output, and you see it is not very difficult. Let's just see. People can share who have their problems, but remember me, I can't share anything. I have to reinstall my R Studio before I can share anything. Can I share my screen? Yes, you can share. There's a lady called the one who had a problem. Can they be promoted to share so that their problem can be sorted?
Please raise your hands such that I can promote you. Okay, I can see here there are 6. Professor, do you remember the name here for these ones which they've raised hands?
Zinela.
Maybe.
She's called Zinela.
Okay, she's already
Yes,
promoted.
yes, I'm here, but I still cannot have the option of screen sharing. I don't know what's the problem.
Okay, let me stop my. Then you can.
I went off.
Oh, you went off, Helen. Okay, now share.
Can you promote me to share my screen, please?
You are already promoted.
I still don't have the option. That's quite strange.
Somebody
I don't
has
know
to
what's
mute
happening.
themselves, please.
No, I've already promoted you. I think you can share.
I have an issue because I don't have the sharing option, the green option that normally allows me to share.
Okay.
Okay, let's have Helen share and we finish that last part, and tomorrow maybe things would have improved and we can share. Me, I can see the share on my screen here, but I can't share anything. Helen, share and we finish the last part in these few minutes left. 6 minutes left. Okay, so Helen, run line 75. So we are running the final model, and we are also going to test the assumptions. So the final model is that one, R squared adjust is 71.26%. We see that it has a residual mean square of 0.719. Almost all of them are significant, except population is just 0.05, which is just significant, so we can let that pass. I think that's it about the final model. Let's just run the residual plots. Ellen, we go back and run the residual plots. Line 80. And then 81. Okay. Run
Yes.
again.
Second.
Is it running?
Yes. I zoom it. Okay.
It's not showing in my side.
Just a minute.
Yes. I think it's clear. You want to zoom it, okay.
You can see it now.
Yes, I can see it. So you can zoom it and we see whether there's any pattern in the data. Zoom it and then share. Stop sharing and share the So if we look at our first graph, residuals versus fitted values, is testing constant as constant variance assumption. I think there is no, do we see any pattern? No, even the red line is almost straight. So we can't say we have any pattern there. Unless if you want to say that there is Thomas, do you see any pattern? I don't see anything. Let's use another eye.
No, there is no pattern.
There's no pattern. When we look at the QQ, which is testing for normality, most of the values are on that dotted line. A few are going away. We can find out whether they are outliers. Then when we go to the scale location, it's also testing constant variance and also fit of the model. We see a random cut of points and the red line is almost straight, showing that the linear model is okay. When we go to residual versus leverage, it helps us to identify outliers. And we see that all those values that are highlighted, like, is it 100? With those numbers, they are falling below the dotted lines. So they are not outliers. Okay. So we are good to go with our model. It does not violate the assumptions under multiple regression. You can go and find out whether the variables are correlated, the independent variables, but that one is done in the initial stages. You run a correlation of all the variables and see which one are highly correlated. But also look at the literature about life expectancy. Which variables are really explain life expectancy? So after running a model like that, look at the variables in literature which have been reported to influence life expectancy. So then you'll be able to discuss your model. Either your variables are more than what has been reported, then you have to tell us why you have 4 variables instead of 2 which have been reported by somebody else in literature. Okay? And then these residual plots, you can either present them or put them in the appendix. You don't need to put everything. Just say you conducted a residual plot analysis and found out that the assumptions under the model are not violated. And if the person is so much interested in seeing the plots, put them in appendix. Okay? Okay, I think that's it about model building. Thank you very much for your patience. And I'm sorry about my laptop. It seems it wants to go for leave, but I can't give it leave because it's still new, so it has to work. Let me hand over to Dr. Helen to give you a heads up about tomorrow so that you come when you've warmed up for another dose of statistics. Thank you very much, Dr. Helen.
Okay, thank you, Professor Susan. Thank you, Thomas, for the wonderful work that you're doing. Tomorrow we are going to look at those of you that were asking about things to do with surveys. So we expect to look at 4 concepts. We are going to look at categorical data and how it is being analyzed. Then we shall look at logistic regression. We shall also look at Poisson regression. So those are the main key things that I'll look at. I've already posted the work in the in the Google Drive. Yeah, it has today's date. So for some of you that are interested, you can check through during the night to see how different codes are run. And then there are some packages that are required, like the CAT that is used to run the logistic regression. So you need it. You need to install the tidyverse for the data manipulation. At least if you've installed all the packages successfully, then we shall be in position to push in very fast. I appreciate your patience as well. Thank you. And we meet again tomorrow. Looking forward for that session. Thanks.
Okay.
Over
Thank
to
you, Dr.
Professor
Evelyn.
Thomas. Maybe he has a
Thank you,
word.
Dr. Thomas. Thank you for supporting me.
Thank you,
When my
everyone. Please don't forget about tomorrow we are going to provide the link for providing questions for Q&A for experimental design. But don't forget about the company we introduced to you. We're going to talk more again tomorrow. In case you want private trainings, you can contact us. For your institution or for your group of people, that should be fine. Thank you.
Thank you very much. Thank you very much, our dear facilitators. And by the way, while you are talking about the flyer, just to note to the participants that Reforum do cover the costs for these trainings, so that you do not ask them why do they do it for free at Reforum and now they want us to pay with our universities. So it is just for noting. But yeah, thank you very much for your patience and for really taking us through this course again on our day 4 as we close day 4. We want to thank our participants for also being here, for being active participants and following really the whole training. So again, we look forward to seeing you tomorrow as we close off the day for this training session tomorrow. So thank you and have a good evening.
Good evening. Thank you, Reforum. Thank you, Salim.